My name is Mariah. If you don't know me, that's Clint's fault. Clint usually is in charge of this meetup, but his sister had a baby, so he feels that that is more important than being here with you. I do not feel that way. I am here with you. Just a couple of things that I want to say, and then I will open the time up to you if anybody's got job opportunities or stuff that they want to add, any anecdotes or quips. So first thing first, I'm being hounded by the people at the Flow Factor conference. I don't know if any of you are involved. It's a local conference happening next week, June 11th up in Sandy. They're supposed to be focusing on AI and or cloud native apps. So they have two tracks. If you're interested in machine learning or AI, that's track one. If you're interested in cloud native applications and or system administration type things, that's track two. You can use this code even if you're not a woman to get 20% off. They sent me, they contacted me 3 ways. They contacted me as Forge Utah, they contacted me through Women Who Go, and they direct messaged me on Twitter. And this was the first code that they made. And then they realized they were talking to the same person on 3 different forums. So, I mean, I told them each time that I was the same person, but they didn't realize until the end. So anybody can use this code to get 20% off. They also have group discounts and whatever. I'm going because why not? So I can hawk more stickers and get more speakers for my meetups. A couple of people that have spoken at the Machine Learning Utah meetup will be there presenting. So hopefully it'll be good. This is their first time, so I like supporting local things, and they're local. Other than that, I invite everybody to join the Forge Utah community on Slack. If you haven't heard my spiel, Forge Utah is the nonprofit that funds these meetups we run out of here at Weave. They're trying to support, I say they, I'm involved. We are trying to enable learning opportunities and career opportunities for the people here in the Utah, Silicon Slopes-ish type region area community. We have a meetup in St. George, so if they're part of it, you know, all of them, we're just trying to enable opportunities. So join us on Slack, follow us on Twitter. I post there all the time. That's the best way to contact me. So yeah, that's my spiels. Does anybody have any other quips and or job openings they'd like to share at this time?
What's the Wi-Fi password?
Oh, Wi-Fi. Did they take my sign down? So Wi-Fi is Weave guest, password Weave rocks.
Okay.
All lowercase.
The obvious.
Anything else?
Until the next thing is different.
Hey, well, if that's the case, I'm gonna turn the time over to Mr. Ryan Ball. He can introduce himself. He works here at Weave. He's pretty cool. So yeah, it's all yours.
Great. So Ryan. I work at Weave. Yeah, so before coming here, actually about a year ago, we were working on a bunch of like ETL processes. And we had also acquired like 4 different companies, all these different companies. And we were in ad tech. And in ad tech, you tend to do the same thing over and over. So you have something called attribution, where you show an ad or do something. You try to say, that was me, I did that. So you attribute it to yourself. So there's various technologies like that. And then there was other technologies like integrations with Facebook. That's not a technology, it's just an integration. And each company had an integration with Facebook to get marketing data from Facebook. Facebook is a pretty closed ecosystem, and getting their data is kind of a pain because you have to play by their rules. It has to be kind of a way that they, how do I say this? It was just always a pain. We had a bunch of providers that we got our data from, but it was always, Facebook was the one that was always paying. And all these companies tried to do this integration and then get the data in such a way that it was the end state was consistent, and it was reliable, and our users could use it. And every single one failed. It sounds silly. Why would something so simple fail across 4 independent organizations? And in fact, our first implementation also was unsuccessful. And so we started talking about, like, why was this unsuccessful? What can we learn from this? And we realized that when we did these processes, we were creating for ourselves traps. For example, if there was some process that needed to get run, we found out that it was very frequently that we had to rerun that process. And then when we had to rerun that process, the results were different in the end. The end state was different. And so we kind of went through and just took it all apart and then put it back together. And this is kind of what we came up with. It's this framework. We decided to make it open source. We called it Task, just simply Task. I didn't like the word job. So that's where this is born. Task. So the idea is that it's really simple to create the different components to run this and just get up and go. So we'll get. If you want to download it, you want me to get it here. Yeah, peace loving task. So this is different. There's I think there's a Go task repo, so this is different than that. So there's 3 different players. You got what we call task masters, and they're the ones that create the tasks. And then you got the task bus, which is the messaging bus for communicating tasks. Right now we have in NSQ. We use NSQ, but it's built so that we eventually want to add Kafka and we want to add some of the other messaging systems. Google pops up. But it's the same idea. It doesn't matter what the underlying technology is. And then you have a worker, and they're the ones that just do the work. This is kind of pretty common language in this kind of problem space. I don't know if people say the word taskmaster. I think that was kind of our thing. Taskmaster.
Fiddle one.
We like The Simpsons. So we like name repos after The Simpsons. So, the message bus carries the task to the workers. And we got our workers. And this is just that same drawing again. The repetition is fun. Yeah. So if you want to follow along, you can. You're welcome to. You can just go get Peace Loving Task, and we're gonna build a quick task master and a worker. There's a quick start on there. You can kind of see how quick and easy it is to get set up. That's what you want to do. I'll give anyone who wants to a moment to stare at the screen and push buttons if they want to. So if you wanted to follow along, and you have that, you can go into this taskmaster right here. There's this quick start guide inside. You go to Taskmaster, you just build it, and then you can run this. I guess I can do it. Build. And then just copy this, just as it is right here. Just running it, and then there's this thing called a type, test type. We'll get into that in just a moment. And then there's some kind of information. And then, so this is just simple Taskmaster. All the Taskmaster does is it creates a task. It's literally all it does. So Taskmaster doesn't even have to be an app ready to go. It could be like a cron job that just spews out this exact kind of JSON object. That's all a task is. It's just this JSON object. You can see it's just got a type, got some information about it, and it just like pretty simple. So there's that. And then this is the entire program for this particular Taskmaster. So it's pretty simple. It just spits this out. This very basic hello world. And again, it can be anything. It doesn't even have to be a Go program. It's just this kind of contract, this task contract. So along those same lines, you could use like Kubernetes to generate your tasks, that kind of thing. And then let's see here. Show this. That's the Taskmaster. And then this is the worker. It's just a syntax. Basic worker right here. And I already have in this directory, I already have a task. It just comes like if you download the repo, it's got it right there. I didn't tell you what to do. And so it just this worker took in this task. In this case, the bus is just standard in. It doesn't matter. It's just a way to transmit the message. So it does have NSQ, but you can just for like when you're staging it locally or whatever, you can just use standard in, standard out. And then, so this is the thing that it did. It said hello world, and then when it was done, it created this done task, which looks just like a task, but it has the same type as up here, hello world. And it has the same created date, and it just says what the result is. And then to create a worker, I'll show you the entire application. Again, it's very simple what it's doing, but the only thing you have to implement is this do task, and then there's a launcher that manages heavy lifting. It's not very heavy, but it manages the heavy lifting of getting the tasks off the bus, and then kind of unpackaging that task and then giving it to the worker. It also manages each worker only gets one task at a time, and so it'll spit up more workers within an application if you want to, or you can have one worker per application. So the net effect is you can do kind of some different architectures with it. But that's pretty much it. And so then here's your little application for workers. It's meant to be very lightweight. It's like a little micro framework. It's not supposed to be. It's supposed to get out of your way. And this was in response to, there's some systems out there that do this kind of, that solve this kind of problem, doing jobs and stuff like that, and have workflows and that kind of thing. But they're, the ones that I've seen are like way overcomplicated. They all have, some of them have these like languages built in that you got to learn. It's like, I don't want to learn some language you invented. It's not gonna help me at all. The idea with this is you have all the power of those and all the power of full programming language go. That's it. You can go. Not have to deal with all that stuff. So this is what a done task looks like. And then that done task goes back to the message bus and anyone can listen to it. Anyone or anything. And that done can act as a signal for other processes to say, oh, this just finished. Well, maybe I need to launch up some other job, or some other task or something in response to that. Let's just kind of show you task versus done task. There was an implementation that they were trying to do something similar to this, and their task, the equivalent object, was like so long, like this long. And I was like, why are we complicating it? But I can see why it's easy to complicate. Because you want to try to describe all these parameters of how your job should run. What we said was, well, the parameters of that job are just right here in the info. And so that has everything you want. If you want to format it a special way, or just have it be a date or whatever it means, then the worker knows how to turn it done. It's kind of this contract. But it keeps it small and it keeps it succinct, and it allows for this kind of thing. Do whatever you want. So common types of info values that we've used were like, we put a date in there because maybe that job represented like they have to do some, like download some file at 1 o'clock in the morning. So it would just be a date. Do this at 1 o'clock. That way, and that's important because there's a distinction between when you say run this for 1 o'clock and run this at 1 o'clock. If you're running it for 1 o'clock, then it's for that piece of that chunk of data. If it's a data, if it's like some sort of ETL process, it's the 1 o'clock data. But if you're running it at 1 o'clock, which is what if your only instigator of workers is like a cron job, all you can say is run at this time. So if you can couple the time from the task, then you can now rerun this anytime you want. It's not just coupled to the passage of time. And then it could be a file location. It could say like, hey, download this file. It could be some other format that you might decide, but it could be pretty much anything you want. They can feed it to describe what you want. It could be empty because it could be like, hey, whenever this task is sent to this worker, then just check on the database just to see if it could be like a health check or something. So workers are where the action's at. We didn't want things to people get bogged down in the task masters. There's actually, I'll show you in just a minute, but there's a bunch of tools we provided that'll handle like 90–95% of the use cases for task masters. And then you can write your custom ones from there for weird things. But workers is where we want to focus all our efforts to implement that just cleanly. Most of our workers that we wrote for these things were short. They become 100 lines long, maybe 1,000 lines long. But and then what do workers typically do? They're just whatever you want them to do. Anything with a beginning, a middle, and an end. It's something that's not a server that just sits there waiting for requests all day. So they could check on some system state. They could process a file. They could send an email. They could send flowers to your mother. Whatever you want to do. So we realized too that with the design of workers, this was like really important thing. that you, and this is a very Go way of thinking, is instead of expanding the language or expanding your tools to fill some problem that you don't even understand, constrain the problem, and we can solve that much simpler problem. So that's the idea with workers too, is you constrain your workers so that they are idempotent, so that the work they do is idempotent. So they do small units of work, whatever that is, and then they need to be task order agnostic, because you don't know, if you need to rerun stuff, you don't even know what the order is going to be. It could be in any order. So first thing is that the workers are idempotent, which means you can run some task, and you can run it again, and the result space, I like to call that result space. The result space is consistent, it's the same, unless the input's changed, right? So like if you were loading records into a database, if you loaded that same set of records into the database, you wouldn't want to append those records again. You'd want to maybe clear out the records from that table and then insert new ones again. But however you do it, the end state has to be the same, no matter how many times. This is like a really big thing. Like, so when we think about designing the workers, if you do this, it'll like changed our lives. During this is like one thing, and this is the one thing that really caused the others. One of the major things that caused the other attempts at these types of problems to fail, because they would have to inevitably rerun it. So then they would have some manual process. They're clearing out some table or doing something, prepping the state again so that they could run that safely again. But the way we prepped ours, it was always safe. We could hand it off. We had plans to maybe even just have like a little Slack chat where you can say, hey, run this flow from this time to this time. Boom, it's totally safe if you need to rerun. So small units of work are really important. I don't know if does anybody run some sort of a job and it was supposed to run every hour, and then at some point in time it started running longer than an hour. Yeah. Anybody? Yeah. Some people run that. Maybe that's like a rite of passage in the UK world or something. I don't know. Yeah. Yeah, that happened to us quite a bit too. And so the idea was to break down, to again design the work to be done in such a way that we could always, the units were so small that they could be done and that those units would scale no matter how big the data set got. This is a slightly different approach to mass scale processing. If you're using this technology, this methodology for ETL stuff, it's a little different than like Hadoop, which has these really brilliant ways to process all this data in parallel across all these machines. It's brilliant, but this again takes the other approach, it's kind of a Go approach, to say, well, let's constrain the problem instead of going through all this complexity and just create very small units. And then that's the scaling. So then you can just spin up your workers, and these workers are all also supposed to be ephemeral. They're supposed to be designed so that they can fail at any time. So you can put workers on like cheap instances in Google Cloud, just spin them up, and then if they fail, the system is supposed to have what are called watchers, which are a certain kind of worker that will make sure that the result space is what it's supposed to be. And then if not, then it'll launch the work again and just be self-healing. So then the result is you can have really cheap, optimized workloads. So we had, when I was doing a lot of this stuff, we had a couple of Hadoop clusters in AWS. I think the monthly bill was like $60 60,000, 70,000. That's, you guys have, I'm sure you guys have kind of run those big bills before. But this kind of stuff, you can spin up. It uses exactly the work that you need, and it spins back down. Does the work. So then the workers need to be task order agnostic. So you can have dinner first, and then dessert, or you could have dessert and then dinner. Doesn't matter. It shouldn't matter. You can run the 1 o'clock work, then the 2 o'clock, then the 3 o'clock work, or the 3 o'clock, then the 2 o'clock. And you can run it again and again in any order. It wouldn't matter. The result space stays the same. Okay, so here's a kind of a sample workflow. So you've got, say, like worker 1 finishes downloading a raw file from, say, a vendor. Then worker 2 picks up the file and transforms it, saving the output to another file. And then worker 3 picks up the transform file and bulk loads it into the database. So this is kind of what that would look like. So worker 1 receives a task telling it to download a file from a secret location. So the type, and usually the type is it's an identifier for the worker itself. So the worker can say, hey, that's me, I'm worker 1. Because maybe they're reading, everyone's reading on different channels on the same topic, or maybe they're reading on different topics. So however you want to architect that. But the type is this worker, and then or is whatever you want to call it, but it's an identifier, it's a self-identifier. And then here's the info, and I took off the created date just to not clutter up this space, but the info in this case could be just the path to download. So the worker knows that his job is just to download files and then put it someplace. So he already knows what to do. You just need to give him the path. So the path in this case is the file. So he says, great. He's handed this, he gets the info, and then he knows what to do with it. And then he downloads it, and then he just copies it, maybe in this case, just to have a copy. Because maybe the vendor has their file somewhere. You just want to have a local copy. So that's what he does. And then it reports back, and it says, hey, I was able to do that. Sweet. And then when he reports back, he sends the done message back to the message bus. And then he also says, hey, I'm going to send out this signal. I'm just letting you know that I changed the file result space. And this is the file, if anybody's interested. Any worker or any taskmaster that might be listening to that can then use that as a signal to create more tasks to some other downstream worker or workers. So you can have very dynamic workflows this way. So then there's a taskmaster that's just listening to this signal. It knows what to do, and then it creates a task and sends that off to worker 2. So worker 2 says, oh, there's a file downloaded here. This is the location. I know what to do. And he knows he's also worker 2. And then, so he does that super eagerly. And then he says, he does a little light transforming. He just wants to be in JSON for whatever reason. And then maybe he gets rid of some fields and combines fields, or maybe brings in other data and does whatever he does. And then the net result is he takes that tidy file, he uploads it someplace. And he says, have a nice day. And then it reports back and it says, hey, I'm done. And then he also says, hey, I created this file, just in case anybody's curious, just in case anybody wants to know. And then a taskmaster is listening intently for those signals. And then it creates a task directed at worker 3. And worker 3 says, great, I'm worker 3. Oh, there's a file, and I know that I'm supposed to take this file and I'm supposed to load it into a table somewhere. So that's what it does. And it does it idempotently. There's no side effects. It can do it again and again and again and again. It's a fairly small unit of work. So if there is some little problem with that batch, whatever that problem is, it's easier to identify which file is the problem, identify the problem. Maybe it just needs to be rerun. And then at least then you're also minimizing the failure domain, right? And then it loads it in the database. And it says, hey, done. And by the way, and there's this message field. I don't know if I went over this, but the message field is just a loose field. It's not supposed to be parsed per se. It's just supposed to be it's almost like a log message. Just human readable thing that just kind of says how it went. Hey, just letting you know I inserted 100 records and it took me 50 milliseconds. Have a nice day. So but then worker 3 also creates a signal and says, hey, I uploaded a whole bunch of records into this table. Just letting anybody know, just in case somebody's curious. Yeah.
I'm not entirely sure. The result space, is that a separate topic? Is that a separate Go channel? Like is that the same topic with a different format of message?
So in this case, result space is whatever, so in the case of like a table, that's your result space. It's the output. It's this like,
where are you sending this chunk of JSON? So far, you've been talking about like queue, right? A message queue.
It'll depend on the worker.
oh yeah. So
you're saying just in general, it's not a JSON. You're just saying like it does whatever it's going to do and notifies something else out in a different system, right? These are all okay. They've all been represented as JSON, so I assume they were all going as like into some other queue. But you're saying like no, just in the database. There's some, or you buzz, or you send a Slack message, or like you can do literally anything. Okay, I see. Sorry, I just got the idea there was like another topic somewhere in another queue.
So you are saying that you can take that response and put it in any form factor?
yeah. Oh, you mean the signal?
Yeah, so whatever it responds back with, anything can ingest that.
Yeah. So these are signals, and signals don't have a specified format. So it would be like, you would say, hey, anything that's a file, a signal, it's going to be like this. So what we did is we said like, oh, a file signal, we like to say like how big the file was.
Are these all independent Go programs?
Yes.
So they're decoupled from each other, write them one at a time, debug them one at a time, and then chain them together.
And so because these can be pretty small, we'll see in just a minute, but we built a set of tools, and part of that tool set is like a couple of bootstrappers, one for a worker and one for taskmasters, so that your whole app is so small. I'll show you an example in just a little bit. So that's the end. Well, almost. One more thing. Let me tell you about a good friend of mine, Task Tools. So Task Tools is a companion. So Task is this little micro framework, and it's fairly unopinionated. So it doesn't, the info, the content of info can be anything, right, as far as the micro framework is concerned. Task Tools says, hey, we're going to standardize on format for info. And then by doing so, we can kind of parse some stuff. And then also Task Tools provides tools for reading and writing the files in like local or GCS, or, S3 or whatever, kind of abstracts all that stuff and just makes common things like that, especially for ETL kind of things, very simple, straightforward. I'm sure what that looks like. So Task Tool provides like reading and writing stuff, database bulk loading. It's really fast. We did a bunch of benchmarks on it and did a bunch of optimization, and it's pretty fast. It's basically as fast as you can get for bulk loading. And then it's got worker and taskmaster bootstrapping. I'll show you kind of what that looks like in just a moment, how kind of straightforward that is. And then it does have opinions on what info looks like. And then it has some general purpose taskmasters, workers, and some utilities for creating a system. Go ahead and go there. This is Task Tools. So these are some of the apps that it comes with. So here's like some taskmasters. A good one to show. So like here's a cron taskmaster, right? So everybody knows what cron is. That's a very common way to start batch processes. That's a good way But if that's the only way, then you're probably going to have some headaches because the passage of time only happens once through a given time. So if you need to repeat something, then that means so this is right with the bootstrapper. That's the entire program right there. That's the entire bootstrapping part of the program. And it provides, if you run one of these applications with Bootstrapper, you can output your config files or your config with populated default values. It kind of takes all that away. Because once we got up to like 30 microservices, we were like, holy crap, we've got to like standardize this stuff. Otherwise, it's going to drive us crazy. Like everybody was doing their configs just a little differently. Like DB underscore username, or then just username, or like it's like all over the place. And you're dealing with so many microservices, it's kind of starts to drive crazy. So this standardizes on standard resources, and the Bootstrapper provides resources, and then also sets up the config, and then also provides a basic way to kind of hook in, right, your configuration and stuff. So it does configuration all that. So this is just like description of the app. It just kind of describes itself. So it's just a description. It's not code. And then this is the actual task master itself. Is the actual code. And this is a longer one because it's a utility, so it's a little bit more general purpose. But you can see it's still not terribly long. It's like 200 lines, 250 lines of code. And then if we go here into workers, it's got a no-op worker. So you can, if you just want to simulate work to be done, it'll like accept the task and pretend to do something, but it doesn't do anything. And then it says, hey, it's done, or randomly say, hey, this failed. So you can mimic the behaviors of the ecosystem at large and make sure that your system is tolerant to failures, to various kinds of failures. Then it's got some general purpose workers that just do simple things like copy a file from here to here, or do some like basic file sorting for CSV and some basic stuff like that. But I'll show you the no-op one. That's the entire application. It's the implementation of do task. So I can do. That's it. There's your bootstrapping process. That's it. So. I don't know if that was, it's kind of it's not a problem space too many people like really start thinking about too much. I don't know, maybe some people do. So some of it might be kind of weird.
Well, when you were asking if we had problems with long running tasks, I mean, every day is, where I work, that's a all day, every day thing. You run a task and that task hangs up and then it hangs 10 other tasks and then the server gets hung up, and then that server hangs up another server, and then that crashes that one, and it just spirals out of control. And you have a Blake go down.
Yeah.
Just to make it even better. Like it's every day we're trying to figure out stuff like that. And which when I was listening through all this, I was trying to figure out how to plug all that into like our everyday stuff. We have hundreds of thousands of alerts going out for every number of different things in our company. It's like, where do you start?
Like building out this kind of an ecosystem.
Well, yeah, like we have so many different servers, so many different products, and everything's reporting back to everything else. And at the end of the day, it's nearly impossible to track down an issue when you get an alert. It's like, I don't know, other than the alert saying, here's the problem, it's hard to track back to which monolith project went down and caused the problem. So breaking things down into little tiny microservices, little bitty tasks would be helpful, but it's like, it really is where you start. You just start, I guess. But.
Yeah, I mean, you just,
with one
Say
thing at a
which-
time.
Yeah,
And it's like, you pick something.
carve out a chunk and then keep your interfaces in place, even if it's, or maybe make some modifications to the monolith. And just kind of, and then just pull out chunks.
So looking for chunks to carve out, one thing is that you go back to those rules that he said about, I solemnly swear to be, idempotent and small, whatever. And so look at the chunks that easily qualify for that, because that's low hanging fruit. Stuff that like already easily qualifies and doesn't take too much work to meet that criteria is going to be a lot easier to move into it. And then you can start get the ball rolling.
We have pretty much anytime a department thinks they have something they need to solve, instead of going to the IT or whatever, just our tech department, they just go and buy a new tool and plug that tool in. We have 10 imaging systems, we have 14 visibility systems, we have like a bunch of dispatch systems, because every department does their own thing. And trying to corral that and just trim that tree over time, it's pretty difficult, because by the time you've trimmed off some branches, they've added more branches. And visibility alone, so I'm working on sending data to a visibility tool. And then we have 2 other people that are sending that same data, just formatted a hint differently to other visibility tools. So we have our database being hit by all these different services. They're doing literally the same thing. So this one's grabbing data, and they're all doing it every 15 minutes or more, because we're sending GPS data for trucks. And so finding a way to make that smaller by doing this one always grabs the data, this one always moves it, and then this one always sends it to these products will be much better than we all grab it, we all transform it, we all send it.
It's just units of work. Somebody owns that worker.
Yeah.
And we started to protect the tables that so we said if we insert the data, we own that table. So yeah, the ownership was important, but then somebody else would retire. If they wanted to, they could read it, but.
Your taskmasters get, because it looks like that's how you're doing most of your coordination between all the different parts. And then you mentioned a watcher. Is that another role of your taskmaster?
Yeah, so a watcher is a special kind of worker. So it still receives a task, it still does work, but the work it does is it watches over the system. So it says, hey, we also call them auditors. So these are the auditors in the system. So they'll go through and they say, oh, this file just got downloaded. So it'll listen to that signal. There'll be a taskmaster who listens to that file being created, that signal. And then it knows to create a task for this auditor. And the auditor then will look at the file, possibly even download it, verify that there was 100 records. Say, yep, there's 100 records here. It did what it's supposed to do. It's actually there because I don't know if any of you run into this, but we would run into issues where we upload to S3 and then say, yep, everything looks good. We uploaded it. And then when something went to go download that file, it wasn't there. S3 didn't. There's some statefulness.
Never happened.
Yeah. Never happens, right? And so the auditors can do that kind of thing. And then if that audit fails, then it says, hey, relaunch this other task again. So the failure is the signal. And there's a taskmaster that says, oh, this failed the audit. Now launch that task again and redo it. We don't care about it if the task is redone because it's all idempotent. So the system heals itself in general, but then the auditors can also be watching the system for errors that they were not able to heal from. And just give reports on.
It's considered to be idempotent. What if you're using something like GUIDs, where they're randomly generated to get certain, and the results aren't always going to be the same.
Yeah.
How idempotent do you go, or what's acceptable?
Yes, so it's kind of like a material idempotency. So we would delete the records, and yes, we had a primary key. We would just delete it with the primary key, and then we just inserted the records again. We would do batches of records that were usually like 10 to 50,000 records at a time. So we could delete that batch of records. And we kept stats on how long everything. So in the DB insert signal, that had stats on how long the insert took and how many rows and everything it inserted. So we kept those stats, but so we delete it, we bulk insert, and so we didn't even deal with updating. And then, yeah, that was okay. It was fast. It was like, so like 50,000 records were, crap, I'm probably gonna
If you
misquote it.
do a bulk insert, how do you, I mean, okay, so it doesn't matter if the same record exists in the database twice? Is that what is that the way that you're saying that you delete? I thought you said you deleted the old record, the old record with the same, duplicate data. How do you do that on a bulk update?
We're not doing bulk updates, yeah. We
Oh,
just,
okay.
to keep it idempotent, we just decide not to
Yeah.
do updates, yeah. We just bulk delete it.
So you're literally saying if the record doesn't make sense, or if it didn't work, or if it didn't do what you expected, you just delete the whole batch and then re-import it again, which keeps it from having update problems, duplicate records, et cetera.
Which was a little trickier in Postgres than you'd think. There's different levels of, what do they call it? Of transaction levels. Thank you. Thank you, nobody. I'm just kidding. Transaction levels. And so the task tools, when you connect to the database connection it's already pre-configured with is the right transaction level so that you won't have problems. So it does the bulk insert will do a delete and insert all in one transaction. That's the right transaction.
So you're doing really small units of work, you end up with thousands of workers and you keep track of all of it with such a simple system.
Yeah, well, we had like, for ours, we ended up with about 30, I think, for a number of systems. Actual programs, and then, but yeah, then you can scale out the instances however you want. You could just have a worker just sitting there like a server, like a little daemon that just does the work. Or you can have it, the launcher knows how to say, hey, only do one task, only do one job, and once that worker's done, shut down the application. So you do that. I don't know if I answered that question. What was your question again?
Yeah, dodged it actually. So yeah, when you've got workers expanding all over the place, right? So this guy makes a worker a task, this guy makes one, and we're all using different formats because we're using info, which is whatever you want in it. And then let's say some new person to the project updates the schema of what's in info, and that causes a break somewhere. How does someone find out that that break occurred in this massive distributed process?
So yeah, see, that's where you'd have your auditors. So the worker would say, hey, I know I'm worker 2. Oh, this isn't the right format or something. So then it fails. It returns the task as failed. And then you have your auditing and your monitoring business. Oh, we've got a problem. This is where it's at.
So your auditors act as your centralized, like I'm going to eat up all the logs I can find and ship them off.
So why go this route instead of, your workers just basically throw things into a queue and have your workers just basically grind against that queue? You have a consumer group of workers grinding against a single queue.
Yeah, that's a good question.
I mean,
That's what we did originally.
yeah, so like, how did you, I don't see anything like wrong with this. I'm just saying, like, what is the point? How do you choose which route to go? Because I think this is neat.
Yeah.
But I'm not sure where I would implement this over the other.
Sure, yeah. So if you just had a queue, how do you rerun things?
How do you rerun them? Well, I'm thinking of against Kafka in particular, where amongst your consumer group, your workers in your consumer group, that basically, you specify whether it's successful or not. So you have record of success, but no, I guess you can't really just rerun other than, I guess you could say, create a new consumer group on the same data or something like that.
Well,
But
what he's doing
doesn't
here is
really
closer
work
to Rabbit than Kafka, right? So
Yeah.
it's closer to like,
So it's
basically it's Rabbit.
it's stateless on purpose.
Okay.
Yeah. It's stateless, even the messaging, even keeping track of tasks. So when a task is done, it's actually creating a new done task. It's a done task. But it's actually not modifying a queue record. It's actually just, so it's not saying, hey, oh, this is the queue. It changed it from in process, because all those states,
queue is the next queue.
yeah, and managing those states became really kind of a nightmare, and it was difficult to know what the actual state was. So the state would say this, we were using Redis originally. The state would say X, but that state never, it would frequently not actually represent the actual state of the system. So we said, well, if the whole purpose of that state, keeping the state of those tasks, and where if it's not actually doing its job, then what's the point of it? So if we just have a stateless system, we focus on the results. Because the task, if the task says I'm done, that doesn't actually mean it's done. It's not like the task is God and says, I think it's done. And it is done. We don't know it's done. That's why you have auditors. So then the auditors verify the space and verify the state.
And you still do have some queuing, right? So like if you had 10 workers of the same type, you were using NSQ channels as the means to divvy it out to one of them.
Yeah.
So you still have a queue there. You just don't maintain a master queue of all your work and update stuff and shovel it through. You basically can just spin up a whole new queue at every single step of the process, right?
And you can use it, Kafka. I just haven't built, or we haven't built.
Once you use NSQ, you won't use Kafka.
Yeah. I wish that was true. I might have to be doing a project so that you have these stateless.
I know.
But it's the design is stateless. So if the underlying messaging system is stateful, that's fine. And in fact, that's kind of cool because then you can literally like replay it and send probably replay the whole thing and have the workers do all the work again. But it's again, it's meant to be state. The problem is it's not you don't replay quite like that because you lose the audit trail of the activity. And so that's the nice thing about having these signals and having all these tasks done is you have this audit trail of like, hey, there was a task created here. And we had like tools that would listen on different channels on the same topics. And then those tools would be like recording the logs. And we can take all that activity and aggregate the activity. So we could get a really complete story of everything that was happening in terms of
Mildly transactional.
Yeah.
So you have a transaction of every completed result or successful result or a failed result. You're not waiting for a task to say it's done, you're waiting for the result to say that it's there.
Yeah. Okay. The task can assert, with the language we ended up using in the end was to say that the task would assert, or the worker would assert that it's like something else would verify.
That's pretty neat having a whole separate micro role of auditing. Because I would have thought it would have had to been plugged into like a taskmaster or something. Very like somebody has to have all the state, but if you just make a smaller role, that's like you just make sure the thing did what it was supposed to.
It's like having a supervisor.
Yeah, no, that was the same question we had. Who watches the watchers? And actually, we were like, maybe we should create watchers that watch the watchers. We didn't look at that part.
So
who watches those? Yeah, who watches that?
So is there I mean, I guess you could, okay, I guess in separating those, you could say that you have like, it's not a end-to-end in terms of, end-to-end in terms of workers to watchers or auditors, because perhaps the worker is significantly more expensive, a bigger deal to do, and the auditing task is smaller. So that's, I guess, part of the reason to separate those things rather than, I mean, again, like, it's a cool idea, but why do you trust that more than you trust the task?
Well, again, it's like the files upload, the task says, or the worker says, I uploaded this file.
Yeah.
And he did the best he could.
Yeah.
As far as he knew, he uploaded it. But then something else could say. Or maybe you did. I'm sure you did the work that
You
you're
could
supposed to do.
combine those two things into the job has to not just upload it, the job also verifies that it uploaded before it actually claims it uploaded it.
It does, yeah.
You could do that, but I think separating those is an interesting idea because, like I said, the number of workers versus the number of watchers could be completely different. Like, it doesn't need to be tied together. So,
Yeah,
interesting.
we had some.
It seemed like in that case, like if the next worker downstream failed, then Ken did say, hey, retry the previous thing. Or no. I mean, what's the difference between a watcher saying this job failed versus the next downstream job failing?
Well, you could have, they could be on different networks, right? You could have be on different, like maybe, like we had some workers that were in our co-located, and they're reaching out from our co-located servers out to S3, but then we had other workers that were actually in AWS or in GCP that were, so you could have, you can verify stuff that way. Yeah. And maybe there isn't a reason to. Maybe you say, you know what? Or you could actually just say, hey, there's a file here. I'm just checking to see if there is a file. But the level of reliability we had to have was like super exquisite. Like it had to be so like perfect. And so we had to handle those issues. And so we were like, that's why we expanded. So yeah, you can kind of gauge and be like, I'm just going to do this. Like I don't need to have another auditor. But then as time goes, and maybe there's like a lot of work going on, and 0.00001% of the time there's a failure, and maybe that's not acceptable. Maybe it is acceptable.
Right.
Yeah. Then you can detect it and heal it, or understand what's going on. It just depends on kind of a choose your own adventure, like how reliable you need to be, if it's worth the overhead and the extra work, and all that stuff. Maybe it's not. You just create a worker, you're done. That's the idea, is that the worker itself is just super lightweight to implement. It's just go. You have all the power of go. You just do it.
You guys use the no-op worker to create something like Chaos Monkey for your own systems?
Yeah, we wanted to go there. We didn't quite get there. I don't know.
I'm gonna cut you off. If you have any more questions, you can ask Ryan. Like, he keep him here all night. He doesn't have any other responsibilities. Yeah, I just want to give him another round of applause. Thank you for speaking.